At 9.2, we're going to cut into a couple different sections as well. So again, these are formulas that are going to be provided for you, so don't stress out about learning them or memorizing them. You just need to know which ones to use and when. So again, our sum formula right here, sine A plus cos B plus cos A times sine B. Okay, and again, there's a whole bunch of different formulas. They are all on the board. Do not stress out about memorizing these. All right, so if we wanted to find the exact value of sine 15, now the book chooses to use sine 60 minus sine 45, but you could also use sine 45 minus sine 30 because that also adds up to 15. So there's no real wrong way of doing this. You just need to find two numbers using only 30, 45, 60, 90, or 0, which isn't really helpful because if you add 0 to anything, it's just 0. So again, you can only use those numbers, and you have to make it equal 15. So since they made it sine 60 minus 45, it's sine A times cosine B minus cosine A sine B. And again, if you know your finger tricks or you know how to figure out what sine 60 is, okay, 60 degrees, you put your 60-degree finger down, sine is the fingers below, so you have 3 fingers below over 2. Cosine, you put your 45-degree finger, root 2 over 2. Again, cosine of 60, 1/2. Sine of 45, root 2 over 2. Well, when we multiply radicals, we multiply the 3 and the 2 together. That's where the 6 is coming from. We'd have radical 6 over 4. And we'd have, so again, multiplying the denominators together. Multiplying the denominators together, we'd have 4. And we'd have root 2. And because they have the same denominator, we would write it as one single fraction. Right there. Here's tangent. Tangent's formula is the most complicated. So again, they broke 7 over 12. So again, you have to think about what can we use with 12s. Okay. So we need these to add up to 7. So we could use 3 and 4. Now, I do want to know that we can't use 1 and 6 because 1/12 isn't one of our numbers. So remember there's pi over 3, pi over 4, pi over 6, and pi over 2. Those are the only things that you can create. Okay, so that's where they're getting the pi over 4 from and the pi over 3 from these two right here. All right, so tangent, since we're using the sum, we look at the sum formulas. We'd have tan A plus tan B, tan A, tan B. And again, the order of these doesn't make any difference. And then we have 1 minus tan A times tan B. Okay, so if you knew that pi over 3 is square root 3, and that pi over 4 is 1, then we'd have root 3 plus 1 minus 1 minus root 3 times 1. Now, here's what they don't show you. They don't show you how they get negative root 2 minus root 3. And I need you to know that. All right. So again, remember when I talked about we can't have radicals in the denominator. And way back in the day, we talked in chapter 3 about how to get the radical out of the denominator, and it's something called multiplying by the complex conjugate. So we take what's in the denominator, and all we do is we simply change the sign of what's in the middle. Why this is going to work is that we'd have 1 times 1. We'd have 1 times root 3. We'd have negative 3 times root 1. So again, this one's positive. Look at that one's negative. Now look what happens with those two middle terms. And then we'd have negative root 3 times positive root 3. Well, remember, root 3 times root 3 is regular 3, and positive and negative would be negative. So now in our denominator, we have negative 2. And in our numerator, we're going to have 3 times 1, root 3 times 1. We're going to have root 3 times root 3, which is regular 3. We're going to have 1 times 1, which is 1. And we're going to have 1 times root 3, which is root 3. So now what we have, we add the numbers together to get 4. If we have root 3 and root 3, we can count them. Look, we have 1 here and we have 1 here, so we have 2 root 3. And this is over negative 2. which can be split because look, that's even, and that's even. So 4 divided by negative 2 is where they're getting negative 2 from. Positive 2 divided by negative 2 would be negative 1, multiplied by root 3 is negative root 3. Okay? Ah, no, stop. All right, so that's where that's coming from. So if I needed to find the exact value of the expression, this is much easier to do in degrees. Oh my gosh, it's so much easier. So again, I can only use the numbers 30, 45, 60, 90, etc. So 105 I can create, I would use 60 and 45. And again, it's addition, so we would look at the sum formulas. So the sum formula for sine A plus B is sine A, and A is 60. And again, the order doesn't matter. Plus cos B, or times cos B, cos B, 45, plus cos B, cos A, just kidding, 60, sine B. All right, now if you knew your trig fingers, okay, 60 sine would be root 3 over 2. 45 would be root 2 over 2. Uh, 60 would be 1/2. Sine 45 would be root 2 over 2. So then we'd have 6 square root 6 plus square root 2 over, so again, these have the same denominator, 4 and 4, so I just created one single denominator in this step. That's the exact value. All right, cosine of 15, again, you have a couple different options. You could do 60 minus 45, you could do 45 minus 30, again, it doesn't really matter. So I'm going to do 45 minus 30. And I do promise you get the same answers regardless of what you choose to use. All right, so we look at the cosine, but we look at the difference formula because we have a minus sign right here. So cosine of A minus B is cos A cos B. So cos 45, cos 30. And then it's plus sine A sine B. So sine 45, sine 30. All right, so that's the hard part, I guess, or the easy part, depending on whether or not you know what cos 45 is. So cos 45 is root 2 over 2. Cos 30 is root 3 over 2. Sine 45 is root 2 over 2. And sine 30 is 1/2. So again, notice these both have the same denominator of 4. Multiplying the radicals, we'd get 2 times 3 underneath the radical, 6. 1 times 2 would be 2. And again, our denominator, 4. And that's the answer. Look at that, same answer. All right, cool. For our next example, these are where it gets harder because we have to be able to create 12s. Okay, so 12 and 12. Now you can't use 1 and 4 because 1/12 does not reduce, and it would have to reduce into a 6th, a 4th, or a 3rd. So again, our denominators can only be 4, 3, or 6. So then we could try 2 and 3. Well, 2 and 3 works. Okay, look at that. That adds up to 5. I can reduce that. So I reduce to 1, which is going to turn into pi over 6. And I can reduce that into 1/4, which would be pi over 4. And again, I'm adding, so that means I'm adding here. Okay? So now we use the tangent formula, which is the hard one. So again, tan A plus tan B is our numerator. So we're going to have tan pi over 6. And again, the order of these doesn't matter. So if you wanted to put pi over 4 in the front or the back, plus tan B, which is pi over 4, over 1 minus tan A, tan B. Tan pi over 6, tan pi over 4, and those are multiplying. So the top is adding, the bottom is multiplying. All right, so again, you'd have to know what tan pi over 6 is. So again, 6 goes with 30 degrees. If you flipped your hand over, you'd have 1 over square root 3. So this is going to be root 3 over 3. Tan of pi over 4 is easy because it's 1, because you have root 2 over 2 over root 2 over 2. And then we'd have 1 minus. So again, this is root 3 over 3. This is 1. So 1 times root 3 over 3 is root 3 over 3. Now again, now we have fractions within fractions, which we can't allow. So I'm going to make this 3 over 3. And I'm going to make this 3 over 3. So again, I didn't change the number. Notice those are still 1s. It's just written differently. So now I have root 3 plus 3 over 3 on the top. Okay, so again, root 3 plus 3 over 3 on the top. Okay, on the bottom, I have 3 minus root 3 over 3. But remember, when we're dividing, what we're actually doing is multiplying by its reciprocal. All right, now this 3 can cancel with this 3. So now we have root 3 plus 3 over 3 minus root 3, which is not simplified. So again, remember what I'd have to do is I'd have to multiply by the complex conjugate. So we keep the numbers exactly the same. The only thing that we do is we change the sign in the middle. And again, we can't just multiply the bottom because that changes the value of our fraction. We have to also multiply the top. So now we're going to have 3 times radical 3. So we're going to have 3 radical 3. We're going to have radical 3 times radical 3, which would give us regular 3. We're going to have this 3 times this 3, so we're going to have 9. And then we're going to have this 3 times this radical 3. So we're going to have root 3 root 3. And I'll simplify that in a second after we're done with our denominator. Now again, our denominator, just have to do this times this, which is 9, minus this times this, which is 3. 9 minus 3 is 6. Okay? So now if we combine our numerator, root 3, 3 root 3, 3 root 3 would be 6 root 3. 3 and 9 would be 12. So I like to put the real number in the front. But again, remember this is all over 6. Well, look at these 3 numbers. This is divisible by 6. This is divisible by 6. And this is divisible by 6. So we're going to divide them by 6. So 12 divided by 6 would give us 2. 6 divided by 6 would give us 1, which we'd multiply by radical 3. And there's our answer, 2 plus radical 3. All right, cool. So one more example. So again, we have to make 1/12. So what could I use? What if I did 4 minus 3? So again, I can't use 1 because 1/12 doesn't reduce. I can't use 5 because 5/12 doesn't reduce. I can't use 7. So it has to be something that reduces into a denominator of 2, 3, 4, or 6. And technically the 2 is not helpful either. All right, so if I have 4/12, I would have pi over 3. And if I have 3/12, I have pi over 4. So again, because it's subtraction, I'm going to use the difference formula, which is cos A, cos B. So cos 3 pi over 4. Why did I say that? Pi over 3. Cos B, pi over 4. looks like rows, cos. All right, and then the second part is plus sine A sine B. Sine pi over 3 sine pi over 4. All right, now again, if you learned your trig fingers, 3 goes with 6. Cosine is root 3 over 2. The 4s are easy because it's always root 2 over 2. Sine of pi over 3, 3 goes with 6. That's actually wrong. Wrong finger, wrong finger. That's 1/2. Yeah, that's right. Okay. 1/2. All right. Sine of pi over 3, 3 goes with 6. So again, pi is root 3 over 2. Sine 3 over 2, cosine 1/2. And then pi over 4, not that it really matters, because it's addition. Anyway. All right, root 2 over 2. And look at that. We got the same answer that we got above. Look at that. It's root 2 plus root 6, which is the same as root 6 plus root 2 over 4. That should be 6 over 4. That is not always the answer, by the way, but it is the answer a lot of the time. All right, so root 2 plus root 6 over 4. And again, you saw both of those were the same answer, except I inverted the 2's and the 6's. And then the tangent ones have way different answers.